We're always told the science on climate change is settled. But what if some of the core physics, well, what if it just doesn't add up? Today, we're going to dig into a scientific reappraisal based on the work of author David Thomas that really questions the very foundation of how we understand our planet's climate. And it all starts with that one phrase, settled science. Because according to this source, when you actually pull back the curtain on the official models and take a hard look at the fundamental physics, the picture that emerges is, well, it's very different. And honestly, it raises some pretty big questions.
All right, so here's our roadmap for today. We're going to start by looking at the standard climate model. Then we'll explore a gravity-based alternative. And finally, we'll dive in and analyze the temperature data itself. Let's get right into it.
Okay, first up, the standard climate model. This is the official anthropogenic global warming theory, or AGW. It's the idea that human activity is the main thing driving climate change. Now, to see the challenge to this theory, we first have to understand exactly how it says our planet gets heated in the first place.
So this right here is the official energy diagram from the IPCC. That's the UN's climate change panel. And it shows the sun heats the ground with about 168 watts per square meter. Okay, makes sense. But look at that arrow labeled back radiation. The model claims the atmosphere sends 324 watts back down. And that's the central paradox we need to wrap our heads around.
Yeah, just let that sink in for a second. The standard model is literally saying that the radiation coming from our own cool atmosphere is twice as powerful as direct sunlight. This effect, this back radiation, is presented as the reason our planet is 33 degrees Celsius warmer than it would be otherwise.
But, according to the source, this runs into a huge problem, the second law of thermodynamics. It's a basic law of physics that says heat always flows from hot to cold, never the other way around, right? You can't heat your coffee with an ice cube. So how can a cold atmosphere, which is about minus 18 Celsius on average, heat a much warmer Earth surface that's plus 15?
Another major critique pointed out in the source is that the standard model relies on a super simplified flat Earth calculation. It just averages the sun's energy over the entire globe, day and night included. But in the real world, the Earth is a 3D sphere that gets blasted with intense, direct solar energy at the equator and gets very little at the poles. And that completely changes the physics of how heat actually moves around.
So if the standard model has these potential issues, what's the alternative? Well, the source material we're looking at proposes a totally different explanation. It's one based not on radiation, but on something way more fundamental: gravity and atmospheric pressure. The key concept here is something called the lapse rate. And you've all experienced this. When you climb a mountain, what happens? It gets colder. That's not a coincidence. It's a predictable physical law. As you go up, the atmospheric pressure drops, and so does the temperature, at a very specific known rate. And this is all driven by gravity, just pulling the atmosphere down on itself.
Okay, now check this out. From space, Earth's effective temperature is a chilly minus 18 degrees Celsius. Now that temperature isn't at the surface, it's found up at an altitude of about 5 kilometers. According to the source, if you just start there at minus 18 and then apply the lapse rate, the natural warming that happens from increasing atmospheric pressure as you come down, you land almost exactly at Earth's average surface temperature of plus 15 degrees. The entire 33-degree warming is explained just by pressure. No greenhouse effect needed.
And this, right here, is what the source calls its smoking gun. This pressure-based model, which comes from the ideal gas law, isn't just a theory for Earth. It actually predicts the surface temperatures of every single planet in our solar system that has a thick atmosphere. I mean, look at Venus. Its atmosphere is 96% CO2, but its insane temperature is predicted perfectly by its immense atmospheric pressure, which is 92 times Earth's, not by some runaway greenhouse effect.
This brings us to water vapor. Now, we're always told it's the most powerful greenhouse gas out there, so more humidity should mean more heat, right? Well, the source material argues that if you look at the real-world data, you find the exact opposite. Take a look at this chart. It compares cities at similar latitudes. The trend is crystal clear. The cities with higher humidity are consistently cooler. Now, this is the complete opposite of what the greenhouse model would predict, but it fits the pressure model perfectly. Why? Well, because moist air which creates a lower lapse rate and, you guessed it, a cooler surface.
Okay, so we've covered the physics. Now let's switch gears and talk about the second major pillar of this argument, the integrity of the temperature data itself.
The claim here is that the warming we all see in the official charts might not be what the thermometers actually recorded in the first place. Here's a really simple way to think about it. Imagine you step on a scale every single day, but each day, someone secretly adjusts the starting point down just a little bit. Over time, your chart would show a clear trend of weight loss, but it wouldn't be real, would it? It would just be an artifact of those little adjustments. So the source asks, could this be what's happening with our climate data?
And this leads us to what might be the source's most startling claim. This chart plots two things: the rise in atmospheric CO2 and the adjustments that are made to the raw temperature data over time. The correlation is an almost perfect 98.5%. The implication here is that the warming trend we see in the official record is almost entirely a product of these administrative revisions, not the original thermometer readings.
This, of course, brings us to the famous hockey stick graph. The critique here is all about how it was constructed. The long, flat handle of the stick comes from what's called proxy data, things like tree rings used to guess past temperatures. But that sharp upward blade at the end, that's totally different data. It's from modern thermometers, just spliced right onto the end. And the argument is simple. You can't just tape two completely different data sets together and call it a single continuous record.
And, it gets even more complicated. The source points to something called the divergence problem. This is where the tree ring data used for the handle didn't show a sharp rise in modern times at all. In fact, it showed a decline. This inconvenient data was apparently cut off, and the thermometer data was grafted on in its place. It's a practice that was famously referred to in leaked emails as to hide the decline.
So, to sum up this position, what's really driving climate? The argument is that it's primarily atmospheric pressure and gravity that creates our planet's base temperature. Then, on top of that, you have natural astronomical cycles, like solar activity and orbital variations, which have driven climate for eons. And finally, a significant part of the recent warming trend may just be an artifact of data adjustments.
So let's do a quick recap of the core challenges presented here. First, a potential conflict with the fundamental laws of thermodynamics. Second, a pressure-based model that explains Earth's temperature without needing a greenhouse effect. Third, that same model works on other planets. And finally, huge questions about the integrity of the official temperature data we rely on.
So why does any of this matter? Well, let's just remember that back in the 1970s, the scientific consensus was warning of a coming ice age. The proposed solution? To spread dark ash over the poles to warm the planet. Today, the consensus warns of catastrophic warming, and a proposed solution is to shoot reflective particles into space to cool it. The diagnosis and the prescription have completely flipped in just 50 years.
And this all brings us to one final thought. Real science is never settled. It's supposed to thrive on questions, on challenges, on tough, rigorous debate. The material we've explored today asks a simple question. Are we engaging in that open process of discovery, or has the debate been closed a little too soon? In other words, is it science or has it become dogma?
Why does bad science persist? It could be stupidity, or insanity, or fraud with billions of dollars in play, or religious-like zeal, or simply just confirmation bias, the inability to comprehend contradictory evidence. The author gives several examples of confirmation bias in action as the probable reason why alternative physics explanations are ignored. Often money interests, career interests, and propaganda reinforcement are involved, but true science should endeavor to break through these barriers. But whatever the cause of persistent bad science, this book can help arm you with a better defense against the basis used for wasteful and reckless solutions that are being proposed for a potential problem that may have a faulty scientific basis. Real science welcomes questions. It demands replication, verification, and challenges to assumptions. Declaring science settled on complex systems we barely understand isn't science, it's dogma. The questions raised here aren't going away. They deserve answers. Scan the QR code to learn more.